So in this limit, again, we're going to substitute in 0 first to see what the value is. So we're going to end up with 1 in the base. Cotan of 0, well, it's approaching infinity from the positive side, so we end up with 1 to the power of infinity. Now this we can evaluate, but it is an indeterminate form, so we want to put it into some kind of ratio form. And to do this, we're first going to we're going to do this as a log. So basically, we're going to say that this is equal to y, and we're going to find the log y. When we do that, we're going to be able to bring the exponent to the front, and we end up with 1 plus x, a base inside the log. So this is using the power rule, bringing this exponent out to the front using the log property. Okay, so now once we've done that, we at least have times and multiplying here, and we could put this into a ratio form. So then we're going to take the limit of this expression. We're going to take the limit as x approaches 0 from the positive side, and we end up with log x. I want to put this into a ratio, so I'm going to, instead of using cotan, I'm going to use tan in the denominator. Okay, so I can evaluate this limit. When I evaluate this limit, I end up with log 1, which is 0, over tan 0, which is 0. There's my condition for L'Hopital's. So I can apply L'Hopital's rule to this. So that's what I'm going to do. I'm going to apply my L'Hopital's. In doing this, I end up with 1 over, let me just put my limit notation in there. So this becomes the limit as x approaches 0 from the positive side. I end up with 1 over 1 plus x. And in the denominator, we end up with secant squared x. Okay, so I'm just going to maybe simplify this. So secant squared in the denominator becomes cos squared in the numerator. I need to make sure I keep my limit notation. The limit as x goes to 0 from the positive side, that expression now becomes cos squared in the numerator over 1 plus x in the denominator. As I plug that in, I'm not going to have a form that I can't use, so I'm going to end up with cosine of 0 is 1, 1 squared is 1, and then 1 plus 0 is 1, so the limit is equal to 1. Now, I found the limit of log y. So what I know is that for that limit, I know that log y gives me 1, so y is our limit, is e to the 1. And so the limit of this expression is going to be, the limit of the original expression is going to be equal to e.